So, when you're analyzing data, you will eventually come to a fork in the road. And honestly, the path you choose from here, it's going to determine not just how powerful your conclusions are, but if they're even valid at all. So, which way do you go? Well, in this explainer, we're going to demystify that exact choice. Right? You've done all the hard work, the surveys, the experiments, the data gathering. It's all there, sitting on your computer. But that big question is just hanging in the air. How do you turn all this raw information into something, well, meaningful? Choosing the right tool for the job is absolutely everything. This isn't just a simple choice between one test and another. It's actually a choice between two completely different philosophies, two major families of statistical analysis. And each one has its own set of rules, its own vibe, and its own unique strengths. To help guide you, we've laid out a really clear roadmap. We're going to start at the crossroads, then we'll explore the two main routes, what we're calling the parametric parkway and the non-parametric trail. After that, we'll put them head to head and finally give you a simple guide to choose your own path. Okay, let's dive right into it. Welcome to your statistical crossroads. This is the spot where we formally meet the two major paths you can take on your data analysis journey. So, first up, we have parametric statistics. I want you to think of these tests as the specialists. They are incredibly powerful, but, and this is a big but, they operate under a really specific set of strict conditions or assumptions about your data. If your data checks all the boxes, these tests can give you some seriously precise and powerful results. And on the other side of the coin, we have non-parametric statistics. People often call these distribution-free tests, and that name pretty much says it all. These are the generalists. They make way fewer and much weaker assumptions about your data, which gives them this incredible flexibility. All right, let's take a closer look at that first route. We're calling it the parametric parkway. It's a fast, powerful, and direct route to your destination, but it has some very, very clear rules of entry. So what are these rules of the road? Well, to get on the parametric parkway, your data usually needs to follow that classic normal or bell-shaped distribution. It also has to be numerical. We're talking measurements on an interval or ratio scale. The groups you're comparing, their spread or variance should be pretty similar. Plus, each data point has to be independent of the others. And finally, you generally need a decent sample size. Think more than 30 per group as a rule of thumb. Now, you've probably heard of some of the vehicles driving on this parkway. Tests like the t-test, which is great for comparing the averages of two groups, or ANOVA, which does the same for 3 or more groups, those are classic examples of these powerful parametric tools. Okay, let's switch gears and go explore that other path, the non-parametric trail. Think of this one as the versatile all-terrain route. It might not always be the fastest way to get there, but it can handle pretty much any kind of data terrain you throw at it. So what makes this trail so flexible? Well, if you have no idea what your data's distribution looks like, non-parametric tests are a super safe bet. They also work beautifully with categorical data, like yes or no, or ranked data, like good, better, best. On top of that, if you're working with a small sample size or you have a few really extreme outliers, these tests are much more reliable. And the tools you'll find on this trail, they include things like the chi-square test, which is perfect for categorical data. Then there's the Mann-Whitney U-test, which is kind of like the non-parametric alternative to the t-test, and the Kruskal-Wallis test, which steps in as the alternative to ANOVA. All right, we've explored both paths, we've seen what they're all about. Now it's time for the showdown. Let's put parametric and non-parametric tests right next to each other to really get to the heart of their differences. Okay, here is the key takeaway, the big trade-off. It's all about power versus flexibility. Parametric tests have more statistical power, which just means they're better at detecting a real effect if one actually exists. But that power comes with a price. You have to follow all those strict rules. Non-parametric tests, on the other hand, are way more flexible and robust, but they're generally not quite as powerful. So you're essentially trading some precision for a whole lot of versatility. Let's break this down even more with this table. Look at the assumed distribution row. Parametric tests demand a normal distribution. Non-parametric? They can handle pretty much anything. Now for typical data, parametric needs that numerical, interval, or ratio data. But non-parametric is perfectly happy with categorical nominal data or ranked ordinal data. And this difference affects the usual central measure. Parametric tests almost always focus on the mean, or average, but non-parametric tests often use the median, the middle value, which is way less sensitive to those extreme scores or outliers. So after all that, after the head-to-head comparison, the big question is still there. How do you choose? Let's boil all of this down into a simple, actionable guide to help you pick the right path for your specific data. I want you to think of this as your statistical GPS. All you have to do is ask yourself 3 simple questions. First, what type of data do I have? Is it numbers, or is it categories or ranks? Second, what does my data's distribution look like? Is it a nice bell shape or something weirder? And third, how big is my sample? Answering these 3 questions will almost always point you straight down the right path. And there you have it. You see, the choice between parametric and non-parametric isn't really about finding the single best test. It's about finding the right test for your data. It's about choosing the path that will lead you to the most accurate, the most honest conclusions you can make. So now, the only question left is, which path will your research take?